Math? No?
Did you guys look at math at all?
Yeah, I've done all of it, but
I haven't.
I'm still not sure if you have to lump. Have you done it?
I've done the first and second part.
Okay, the third question is easier than the second question.
My question was, binomials, right? Like the O1, O2, O3, whatever. And you have the expected value of each group. Is the expected value based off the type of distribution it is? So like for the uniformly distributed, it's just the probability times the number of trials. If it were like a binomial, then the probability is a binomial distribution. The expected value is like the expected value of a binomial, like whatever equation is, like
The expected value is always the probability times the number of, or sorry, which expected value like E at X?
or how about E, like
Or capital E like
E, like if you have O1, then you have E1.
Right,
Expected
yeah.
value for the group. Is it always the
Those are always
probability
probability
times the
times
number?
N. So
Okay,
probability
okay.
changes depending on what you're doing.
Okay, good.
Because like
For a probability of
binomial,
0.5,
finding probability.
What happens on a binomial for a probability of 0.5 is it does this.
Yeah.
Obviously, because that's what you're gonna see if you just plug in the numbers. So you have your n, you have y0 through 6, 0 through 5, so you have 6 instances, and you have p of 0.5 and 1 minus p of 0.5.
Right.
So you just plug
That's
those
the
in,
probability.
get
multiplied by
probabilities
the number of trials.
multiplied by the total number of things, and you get an expected value. So, well, as long as you round it so that when you add everything up, you get the same total number.
That's the only thing where I get a bit confused is not the actual like finding the probability or anything. It's when you have a lot of groups of things, it's what group of things to take the number from, like what's the end value, how many, or I don't know.
Yeah.
It still gets like I can be going through a problem and all of a sudden like
Yeah, for
you know,
binomial,
like
like,
it's just like great.
if he doesn't straight up give you an n and p, and if he gives you a situation where you have to figure out n and p instead,
Oh,
it's like,
God, yeah.
Okay, so what I just figured out here, so normally uniformly distributed, the probability of being in each group is like 1/5.
it's the same probability. Yeah.
Normally distributed, you use the Z table,
You have to use the Z table, yeah. You have to estimate
which gonna be exact,
yeah.
and binomial, you have to do the probability and choose R.
And choose y, p to the y, 1 minus p to the n minus y.
Oh, I literally just figured that one out.
Yeah.
Yeah, dude, if you know how to find expected, you put it in the chi-squared formula. And if you find your degrees of freedom, and then you, with your hypothesis and value on
Which
curve,
value that you add up all the E of, is it, that has to like equal?
all the e's.
Yeah.
Oh, okay, so like your observed has a total amount of soldiers total, 150 total.
Yeah.
So the total amount of expected
Should be one.
should be, because the probabilities should add up to 1, then the total amount of soldiers should amount to 150.
All right, good morning, officers. Morning, sir. Please help me with the attendance. Mr. John, Mr. Aaron, Mr. Joe, Mr. Riley, Mr. Greg, Mr. Spencer, Ms. Aaron, Mr. William, Mr. Headley, Mr. Scott, Mr. Mark,
Casey.
Mr. Casey, Mr. Juan, Mr. Dylan, Mr. Jacob, Mr. Mike, Mr. Callum, Mr. Cole, Mr. Jeremy, Mr. Charles,
Jeff.
Mr. Jeff, Joshua, Mr. Joshua,
Steven.
Mr. Stephen, Mr. Nathaniel,
That's it.
Mr. Vincent. Gentlemen, please spend the next minute to finish up what you were saying.
Skip.
This goodbye, honey, I'll miss you. I won't talk to you until the end of the session.
Past 10 plus the other class.
Are you guys ready for scribbles on the board?
Huh?
Oh, I heard Super Bowl.
I'm recording it, so.
Monday, right? Yeah. Around that.
I thought it was a
Monday,
changed so many times now, I don't even fucking know.
at Alpha 3050 1100. You concur?
Yes.
Will you be there? Yeah, that's what mine says. Mine says, if yours says differently, so I'll come to where you are. It says ASD 400 DND is on Alpha 3050 at 1100. On Monday, April 17th. Well, that's what I have. If you have any different, please email me or come where I am. So we are concluding the course. I'm not planning to teach anything new today. Just going to give you a heads up what will be in the exam. I'm going to look at your report to see what the progress is. I'm only looking to give you heads up alarm. To tell you that if you give me this report, there are chances that I will hold you here to complete it. So I may not fail you, but I'll say incomplete, and you have to finish it. That's the only thing I'm going to give you. Heads up, warning, this is not a complete report. Other than that, I will mark them when I receive it. So if I see a big alarm that your report is not going to give me what I'm looking for, I'll give you the alarm now, or I'll tell you what is missing. Other than that, I'm not evaluating it, right? Okay. Any burning questions in your mind? Of course, you've done a review of your own material, and you have questions about that material. I am at your service to answer those questions. So,
Is there going to be anything on the exam regarding? You said you like had to cover the stacking of materials such as the 90-45, -45 zeros. Is that going to be on the exam, or was that strictly a MTS 300 type of question?
the composite material, I have examples of a composite material. I want the student to have a set of directional laminate composite material. That's the end of it for this course.
Okay.
In Advanced 700, we come back and we really design a plate made of laminates. So now I want the student, I give you examples of it. I want the students to be able to find composite properties like that, or the forces that are carried by matrix and fiber in a combination. What I am interested is aligned fibers, but in both directions. So this is called transverse, and this is called parallel or axial. You see, that's what I'm looking for. This one here has EC is a linear. Remember, this one is a linear. That's transverse is 1/EC. So it is not linear. So that's what I'm interested in, composite material. So I have a little bit a heads up of what type of questions I will have in an exam. That may trigger questions. You know, you might have done some review, and this may trigger some questions. So if you don't have really a burning question right now, I'll give you the sample exam I'm planning to have, and then you'll ask questions on that. Gentlemen, sir. Gentlemen, sir. Review. Good. not treat this. This is my exam or it's last year's exam. It is not. I just put it up together this morning. Please stay with me. Let me walk you through it. If you're reading question number 3 while I'm talking about question number 1, you will miss an important message.
Sir, do you have 2 more for?
Yes, sir. What's happening? Right?
Would you have next one?
Oh, that's what. Is there anything? So let me just again, please don't take this as your exam. There are many other questions in the handout that I gave you, but this gives you a sense of the level and type of question I may ask. So look, you guys are not going back this summer, no? Do I have you for 2 more courses this summer? You have a course this summer?
I think you have us for half a course split with Dr. Caritas, yes.
Aircraft stability and control, I think he teaches the first half, and then I'll coach you the second half. So better listen to what he says, because I'm going to build on that. So that's aircraft stability control. But I have 700 courses. Now you guys?
Not sure. You don't know our full schedule yet.
Yeah.
So I have 2 different classes. Good summer. Maximum shift between AC and CG. So I'm looking at an aircraft and say, well, this aircraft has a tail, has a wing, has somewhere has a CG, and that CG has a weight acting on it somewhere in aircraft. It's called an AC, aerodynamic sensor, when an air applies. So lift is applied to an aerodynamic sensor, and weight is applied at the CG sensor. And of course, we want a tail in this direction, up or down, depending on where the CG is. Of course, we'll talk about that in an aircraft stability control course. So if your CG is ahead of your AC, so there's a different moment, and if it is behind the AC. So I'm asking in this question is, this is a static margin or the distance between these 2. So it says the difference between them is 13 inches, so I'm saying 13 inches there. Tell me where the tail edge staff is that can produce 900 pounds. So in this scenario, when the tail is acting upwards and is producing 900 pounds, so the question is asking for the length to the tail of an aircraft. So there exists a moment due to a CCG shift, so it's called a static margin. There exists a moment here in that direction, so that is the residual moment exists. That moment must be interacted or reacted by the tail. So you see that the big moment that I have there must be interacted by 900 times LT. As simple as that. So,
The CG and AC are along the same axis, correct?
no, we don't care. We don't care. Even if they are up and down, they produce the same moment axially. Doesn't matter their height.
Okay.
You see what I mean?
Yep.
You see, you have a load that is going here or a load that is initiating here, they will produce the same type of moment in x-axis.
Right.
So you see, again, this is an edge stop, and these are all assumed numbers. Don't let that bother you. That don't ask questions such as, what is this lift, upward or downward? Is this a static margin, negative or positive? Is this a channel or not? It doesn't matter. Our student needs to understand that there exists a moment because of that shift. That moment must be reacted by an edge stop at a distance LT. We're looking for that LT. Now, what happens when CG and AC coincide? There won't be a moment. So that M becomes a 0. If that M becomes 0, LT cannot become 0, right? Could the LT become 0? Never. The tail doesn't move. So what can be 0? Lift, on on the LT must be 0. Not LT itself. That L must become 0, right? So when I have L equal half rho V squared S of the tail and CL of the tail, so CL of the tail, none of these can become 0. Density cannot become 0. Velocity cannot become 0. ST, unless we drop the H staff, cannot become 0. The only thing that can become 0 is CL. So if a CL is 0, means elevator deflection is 0, isn't it? Look, I have a symmetrical airfoil. Symmetrical airfoil has an elevator, and the elevator angle must be 0. Deflection angle must be 0. Delta equals 0. Then therefore hinge moment equals 0. There is no moment on that elevator. So these are side questions, you know. People may ask. Estimate moment on elevator hinge. Then you say, well, there is no moment on elevator hinge when the CG and AC coincide. What if it wasn't? Now that you have a dimension, what does that mean here? It means it will have a lift, and that lift is generated by deflection of elevator, because this doesn't have a camber. This is a symmetric airfoil, and a symmetric airfoil CL alpha, as Dr. Bardakji is showing you, the CL alpha of a symmetrical airfoil looks like that. Right? This is the CL alpha, and this is CL max. So, once you deflect the elevator here, what you actually are doing is elevator deflection. When delta is not equal to 0, then you're producing a camber. Yeah, look at this camber. So when it was a straight line, now you're producing the camber by deflecting the elevator. The camber and elevator, what does that to do to this graph? It just shifts it up. Does it? So Dr. Radaki has been explaining that. So what is this called then? This is called CL9. CL at alpha equals 0. So if somebody gives you a CL alpha of a deflected elevator with numbers, we should be able easily to go a deflection angle, let's say is equals 10 degrees, and then from there to see what type of lift does it generate. So if you have a CL alpha graph, you should be able to draw a CL from a CL alpha graph that is shifted from a symmetrical. This is a symmetrical, this is a camber. So I'm not testing you on aerodynamics, but you should be aware that that's where the forces come from. Second one is asking shift between AC happens in a takeoff. Oh, did I say that? 10 to each. Oh my God. Did I do that?
RNG.
Did I press
Control C.
Control C twice?
Control V twice.
You don't want to know what I was drinking last night.
So for that question, we just find the moment from AC to
Is that
CG.
what you were laughing? You don't tell me what you're laughing about. Sorry.
So to finish that question, we just find the moment between AC and CG multiplied by the weight, and then we just divide by 900, and then we get the distance in inches, and then we just divide by 12 if we want it in feet.
Yeah, easy. Now.
Just want to make sure it's easy.
No, I will not make it. Yeah, it is not as easy to look. Tell me.
Wait, John does
Tell me
writing
which one, why do you think the moment here is a W times that distance? Is it?
So
W
the
times that
forces after the
why do you think W and L are equal?
Because it's takeoff. So are you assuming that the lift is just at the moment of takeoff?
So you have to assume it's a steady level flight to have these two equal. Correct? But if this aircraft is climbing, it is feeling a G-force, these two are not the same, so then what is the couple? Moment is to the center, if they are not the same. This is algebra, right? This make 200. This make 200 says a couple, this is an F, and F produces a moment that is force times the distance between it. This is a couple, right? This is a couple. So force times distance, that's the moment. But what if these two forces are not equal? This is like that. So this force is big, and that force is small. So now what is the moment between these two?
It's closer to the smaller force.
Sorry?
It's closer to the smaller force.
The center of rotation it is,
Yeah.
but I'm looking for the moment. What moment does it produce? Because right now this aircraft is climbing. It is not an static, so we can't do a static analysis.
It's the force.
Oh, the moment about where?
The moment about the centroid here in the middle. There exists a centroid here in the middle. Look, there's a centroid. The student says there exists a centroid here.
Okay.
Because in the middle of them with respect to the forces. So now we say there are two moments. I'm going to call this a D1 and a D2. And there are two moments, F2 times D2 plus F1 times D1. So there are two moments exist here.
In reverse
But
magnitude.
this is a little too much for this level, even though I said it is climbing, but you can assume a steady level flight and produce a couple. Now lift and W are the same. And it is as simple as you see.
Okay.
This is the bonus mark to bring your confidence up at the beginning of the exam before you see my question number 3. Yeah, this is just pushing students so that you don't fail the course. Sorry about that. Number 2 is a
Yeah, we take those.
Yeah.
I need those.
Weight, I want you to be able to calculate the weight of an aircraft because aircraft structure is mostly about the weight of an aircraft, mostly. So again, mostly about the aircraft, I want to know if I can calculate CG of an aircraft. You know, you do weight and balance on your aircraft all the time, don't you? So if you can calculate the weight of a component with the arm of a component, then I will be happy.
That was just
Weight of a component
kind of left side part of it.
with a CG. So if you have a skin, it's a circular skin, diameter is given, and mean diameter, gentlemen, is the center of the thickness. This is the mean diameter in the middle. This is an OD. This is an ID.
Oh, for this identification.
And this is the mean. So, but the thing is that this is ID and OD is so large compared to the thickness that in reality, if you take the ID or OD for your calculation, the difference at the end will be 0.2% because the diameter is so big compared to the thickness. So, I'm asking you to find the weight. So the diameter is 9.6 feet. I'm talking about mean diameter. Skin also will have different thicknesses. So if you look at aircraft fuselage skin, you may have a skin that is different diameter, a different thickness everywhere because of the way we attach things to the skin. The skin could have, let's say, 5/8 of an inch thickness at some areas in here, for example, where the carry through passes. The skin could be about 1/2 inch, for example, in an area that is not stressed, other than pressurization and empennage. And the skin might be different thickness depending on the area. For bay, for example, you see this bay here, APU bay, might be APU bay, might be thinner. So what I said was an average. Of course, I can take an average and say the average skin thickness is given. So average T in here, I say it is 3/8 of an inch. So, and that was the last one here. Could be 1/2 to 1/8. So if I don't tell you that average, can you take an average? You take a linear average, I'm sure the student would take a linear average. This is that thickness plus that thickness plus that thickness divided by 3. Can we do that? Yes, if we assume the lengths are the same. Otherwise, it is thickness times the length plus thickness times the length plus thickness times the length divided by all the lengths. You see? So we divide the average based on the length. If we assume the lengths are the same, of course the average will be average of the 3. So average thickness is given, section length is given. So that's the section that we are calculating. This is the section width. So the skin that is made of three different thicknesses is at 18.4 feet. So that gives you the length of it. And density of the aluminum, and it's 0.1, we know that. But it is a little higher because the average density, because of fasteners. We will have metallic fasteners, steel fasteners. We will have gussets that are not aluminum, so it will have a mean or an average density of 0.13 pound per cubic inch. So again, when I give you the density in cubic inch, very, very careful with the units. So that all feet must be in inches, or you can recalculate the density per cubic foot instead of cubic inches. We can multiply the density by 12 times 10 to the third if you want to convert it to the pound per foot cube. So I want a weight of an aircraft and a CG of such an aircraft. So if I have the same diameter and an average thickness assumed for the section, where is the CG? Right in the middle. Provided that the fuselage doesn't have any paper, so your CG will be right in the middle. B part of it, I'm asking for a scale. Now I know what has happened. I don't have a computer in my room. They took my computer away to fix it. I logged into my coworkers, Dr. Bardaki, to print it, and I printed the wrong one. Sorry about that. So you read that the question number 3, B is missing an element. Wings, top and bottom skin, root chord 3.7, tip chord 2.27, 2.2, span of 25 meters, average thickness given, and a mass density is given. So what am I looking for? Weight. Weight. And the relationship between the weight and the mass is acceleration due to gravity. Okay, now let's add to this skin access holes. So if it was a top skin, we can assume there is no access holes. If it's a bottom skin and people tell you access holes, you subtract the access holes from the total width. Number 4 is giving you an MTOW, 2200 pounds. This is CL max. You see there's a CL max here? This is right there, CL max on top of the CL alpha. CL max is 1.235. I want the required wingspan. B is a trapezoid wing, is the CT and CR given, sea level condition, density given, during the takeoff speed of 85 miles per hour. This is a takeoff. Because the climb rate is not given, you don't know what the inertia on the aircraft is because of the climb rate. For that reason, you say it is a steady level flight, even though it is taking off, but the N felt by pilot is 1. So what are we looking for? First, we look for S required, surface area of the wing required to overcome the lift. So say lift equals W at steady level flight. And then from there we'll calculate that is the lift. The lift then requires an S. S can be calculated with the CR and CT. Then B will be the only unknown. And B is the span. Span is tip to tip. Student says the span, you want the span of both wings. There is no both wings. Aircraft has only one wing. If the aircraft has 2 wings, we call it a biplane. And then there is no left and right, starboard and port side. The aircraft always has 1 wing, but it has 1 wing has 2 skins, top and bottom. So you can assume the top solid, and then I'll give you access holes at the bottom that you need to deduct from the weight. Okay, that's easy. The third one, was 8 of the following, sir.
Just about the access holes, I don't
Yes, sir.
understand why you'd be taking that off, they have covers on them.
Yes, you're right. But I'm asking for the skin weight, not the covers. The skin doesn't have the cover in it yet. So it's a wing assembly, and I have to add everything else to it.
Okay.
If it's a wing assembly. Access holes are anything that is detachable from a component is a different component from aircraft. Anything that can be detached must have a different number. So access holes are not part of the skin, they're access holes. And then you can always, gentlemen, you can always assume and say, assumption, the access hole is not part of the weight. Assumption, access hole is part of the weight. And I will read that assumption and I will mark it based on that assumption. Weight of the following 6 feet long center wing. So students says, where is the 6 feet? The 6 feet is the length of the box. So that's a 6 feet, it's a wing box. And I have a wing box shape at the bottom. So 6 feet is the B, is a center box, it's aluminum, density is given. Now, the top